We are looking at the electrolysis of a concentrated solution of X. So we are asked to determine X because we see a brown coloration at one of the electrode and a deposit of a metal on the other side. So the first thing is we look at option A. So option A is silver iodide, so it's AgI, which you know that it is a solid. It is very insoluble in water. So it cannot form a solution. Immediately A is out. Okay, next we look at sodium bromide. Now you know that sodium bromide is sodium is a very reactive metal, and we are looking at a solution here. So sodium can't possibly be discharged as a metal. So again, B is out. Same thing for potassium. Okay, so potassium, very reactive metal. You put it in a solution and do electrolysis, you can't possibly get potassium metal out of the solution. Yeah. So by elimination, we know that it is going to be copper bromide. So copper 2+ is going to be discharged as copper because there is a reduction. Okay, and the bromide ion is going to be discharged as bromine gas. Yeah, so this is a brown coloration. Yeah, the bromine gas is a brown, and this is the metal. Yeah, so the answer is D. Okay, so when you are doing electrolysis of dilute sulfuric acid, you should know that effectively we are doing an electrolysis of water itself, because SO42- you cannot discharge it, and we are only dealing with H+ and OH- in water and from the sulfuric acid respectively. Okay, so I've written down these two equations here. We have the cathode reaction, okay, which you have the H+ getting reduced to give you H2, and at the anode reaction you have the OH- being transformed into oxygen and water. Yeah, so remember what I say? I said that whenever we need to compare equations in electrolysis, you got to make sure that the number of moles of electron in the two half equations are the same. So over here I need to change it to I need to multiply this equation by 2 throughout, because the number of moles of electron here in the two half equations are different. So this one I will change it to a 4, and this one I will change it to a 4, and this one I change it to a 2. So when you have the number of moles of electrons the same in the two half equations, you can then go on to compare the products. In this case, we are looking at the oxygen here and the hydrogen here. So we have a 1:2 relationship. So if we have 50 cm³ of oxygen, we will therefore have 100 cm³ of hydrogen. Yeah, and it's as simple as that. So in question 13, we are looking at a equation here, and we are asked to find out the increase in oxidation state of sulfur. So we are not sure of the oxidation state of sulfur in S2O3 2-. So I've written down, why not let the oxidation state of sulfur be X. So 2X plus 3 minus 2, which is the oxidation number of oxygen, will give you -2, which is the charge of thiosulfate, and X you end up calculating X to be +2. And if you look over on the other side, HSO4-, hydrogen has an oxidation state of +1. Sulfur, we are not too sure, so we let it be Y, plus 4 of the oxygen that we have in the formula, each one having a -2 oxidation state. Overall, you get a -1 charge on the HSO4-. So when you calculate this, Ly ends up to be a +6. So from +2 to +6, you have the increase of 4. So it's a +4 increase. We are dealing with 4 separate electrolysis experiments over here. and we are assuming that electrodes are inert, and which of the following changes in pH of a solution is incorrect. Okay, the keyword here is incorrect. We got to make sure that you are choosing a false statement. So let's look at option A. So option A, we have looked at it before. We are doing an electrolysis of dilute sulfuric acid, which means that we are actually breaking down the water only. So when the water gets broken down into oxygen and hydrogen gas, you get a decrease in volume, which means that the sulfuric acid originally in the solution is now in a lesser volume. So the H plus concentration will actually go up, which means that the pH will come down. Okay, so A is a true statement. Yeah, it's true. How about dilute sodium hydroxide? You have Na here, Na plus. So you get Na plus and H plus migrating to the negative electrode, and you get OH minus migrating to the positive electrode. Now, if you were to compare Na plus and H plus, which one will get discharged? I hope you say is H plus. So H plus will get discharged as H2, and OH minus will get discharged as oxygen and water. So effectively, it's the same as the case of dilute sulfuric acid. The sodium hydroxide has really no effect on the product of electrolysis. It is just added to increase the conductivity of water. So effectively, we are doing an electrolysis of water, which means that water gets broken down. We get less and less water inside the electrolyte. Sodium hydroxide is now being stored in a lesser volume of water. So it means that the OH minus concentration will go up. H plus concentration relatively will go down. So you have a increase in pH. Yeah, so this is still a true statement. How about for concentrated sodium chloride? Yeah, so we have Na plus, and we have H plus, we have Cl minus and OH minus. So these are the things we got to consider. So Na plus and H plus, which one will get discharged? H plus, because Na plus is too reactive. Cl minus and OH minus, which one will get discharged? Cl minus, because it is concentrated, right? So when you have the H plus from the water being lost at H2, but the OH minus remains intact in the solution, relatively speaking, you get more and more OH minus inside the solution. It is getting more and more alkaline as the electrolysis proceeds, so the pH will increase. pH will increase. Yeah, so it means that this is still a true statement. If we look at copper sulfate, concentrated copper sulfate, Cu2 plus and H plus, SO4 2 minus and OH minus. So Cu2 plus and H plus, which one will get discharged? Okay, it is Cu2 plus get discharged. SO4 2 minus and OH minus, which one will get discharged? OH minus. Yeah, so you get the OH minus of the solution getting discharged as oxygen and water, and you get the H plus left behind. So relatively speaking, there will be more and more H plus compared to OH minus as you proceed with the electrolysis. So the pH level of the solution should actually decrease. So pH will actually drop. Yeah. So but it says yes, increase. So it's wrong. Yeah. So D is a false statement, which is, in our case, we are looking for it. Oh, we have another question about redox. So in this case, we are asked to determine which of the following statement about the reaction is true. I always like to do redox equation by writing down all the oxidation number, so that I really get a very quick understanding of what is being reduced, what is being oxidized, and I can really get to the truth of the statements really quickly. Okay, so I've written them down. Okay, so Cl minus over here, I have for chlorine we have a -1 here. For ClO3 minus, I have a +5. H plus here, I have a +1. Cl2 here is an element, so it's Cl0. So water here is H2O, so H is a +1. Oxygen in both before and after will be a -2. So which one of the following is true? Yeah, so hydrogen ion is oxidized to water. Not true, because hydrogen has a +1 oxidation number before and after the reaction. So this is no, not the one we are looking for. Chloride ion is the oxidizing agent. So if we are looking for an oxidizing agent, it should therefore be reduced. So from -1, I should expect to see an oxidation number that is lower than -1, which I don't see. Yeah, which is 0. So again, this is a false statement. This is false, and this is false. Let's look at D first. The oxidation number of chlorine in the chloride ion is +3. No, this is quite a easy statement to distinguish, because we already told you that it is chloride 5. So it's chlorine +5. So how can we say that it's a +3? So immediately that is out. Chlorate 5 ion is reduced to chlorine L. That is true, because chlorate has a +5 oxidation state, and it is reduced to 0, so which is less positive than +5. Yeah, so C true, D false. Yeah, so answer is C.